York, it's Ask an Engineer.
Hey everybody, and welcome to an Independence Day Ask Engineer. It's me, Lady Ada, the engineer. With me is Mr. Lady Ada. We're in the Adafruit factory. It's July 4th. People are eating hot dogs, setting off fireworks. But we're here. We're going to talk about electronics, engineering, the maker stuff, community, whatever's going on. Here, broadcasting live from downtown Manhattan. We've got an exciting show for you tonight. We got a lot of new products, a lot of news, a lot of guides. Let's kick it off. Why don't we do this thing?
All right, on tonight's show, the code is America Day, celebrating America. Independence Day, America Day, code is 10% off at the Adafruit store all the way up to 11:59 p.m. Eastern Time. We have, yay,
America,
LEDs,
yay,
flags.
LEDs in flags, LEDs on flags.
And purchasing stuff supports us, a USA company. We make electronics here at the Adafruit factory. We like hiring people and paying them money and all that stuff. So when you use the code America Day, that's what you're supporting.
And we're American.
Yep. Okay, show and tell, people around the world showing and sharing their projects. Lady Ada will go over those. Pack the mailbag, we'll stop by.
Hey.
Your letters to us. Time to travel, look back in the world, makers, hackers, artists, engineers, some news and more. Some factory footage from here in the Adafruit factory. 3D printing, new products. We'll answer your questions. We'll do that in Discord. If you haven't already, go to adafruit.it/discord and go to the live broadcast channel. Do a trivia question, we'll give away something, all that and more on, you guessed it, Ask an Engineer. Okie dokie, Lady Ada. Let's pay some bills first and give people some information. Don't forget, code's America Day. 10% off the store, 11:59 p.m. When we have free stuff in the store, you get more the more you buy.
That's right.
I think Circuit Playgrounds will be back, but I think right now it's only the Perma-Protos.
Yeah, whatever we have in stock.
And UPS shipping.
Yeah, and UPS, of course, we always have the UPS ground shipping for orders $199 or more. $99 or more, you get a free Perma-Proto half-size breadboard. And when we have them in stock, Circuit Playground Expresses for orders $299 or more, you'll see on checkout what freebies we have available. And of course, you get every freebie below that level when you, when you get your $299 and $199, you get the $199.99. So add more to your cart. There will be more free stuff, and it will tell you what's available. All
right, next up, if you gonna use some shipping in the U.S.,
stuff.
UPS ground is the way to go in the U.S., followed by postal, and for international, do DHL. A little bit of a reminder: we were not shipping today because there is no postal pickup, no UPS pickup, no DHL pickup, but we'll be shipping.
Because it's America Day.
Yep, we'll be shipping everything tomorrow. And then also tomorrow, same day's back on because today there was no same day. 4:11 a.m. Checkout in the store. And if your zip code is in Manhattan and it's one of the places we do same day,
you'll get it.
Yep.
Same day.
Lady Ada, for show and tell.
Yeah, we actually had a lot of people showed up.
Right before the fireworks, people showed their fireworks.
They fireworked it up.
Their projects and more. What was on the show and tell?
Okay, start off with Phil B. from Adafruit West. Famous for the TFT Eyes project that will not die, as he likes to call it. People love his eyeball code. Well, he ported it to the SAMD21, so it'll run on a Trinket M0 or a Itsy Bitsy M0 or a Feather M0. We love the SAMD21 processor, and he got some DMA stuff going on it so that the eyes look really great on our 128 by 128 displays. Super fast, moves around nicely. So Halloween starts now, so get started on that with his eyeball code. Code is on GitHub. Nan Pedro showed off this week's 3D Hangouts project. It's a papercraft button inspired by the Nintendo Labo push button. This was made with a Cricut cardboard cutter, papercraft cutter, using like a thin cardboard. And they were like, oh, it seems kind of like a thing that you would push to like detonate something. So they did. They turned it into a fireworks detonator with some Canthal wire and a couple batteries. There's no coding in this project. You just solder up some battery holders to the wire, and when you press down on the papercraft button, a couple feet away, the wire will ignite the fuses on your fireworks. They had a great live demo of that because it's the 4th of July, so right on time. Chris Young got a NeoPixel 60 ring from us, put it together, and he made a clock. And he's like, well, I want to make this clock more than just a clock. So he added a Music Maker feather wing and wrote code for it to chime like Big Ben. It has various audio modes. It'll say the time. I think he added it to start just for the chimes. And he's like, well, I want it to have to speak the time. So he has this voice that will speak the time if you want. It has various modes you can go into, and it uses audio prompts to tell you how to like configure it so you can have it like have it chimes on quarter hour or half hour or full hour, mute or not mute. If you want to set the time, so check it out. It's a really cool clock. And then Michael also came by with a round clock, not a 60 LED ring, I think, maybe a smaller ring. This one uses like some sort of wireless chip to do MQTT and gets data for temperature and humidity, which is displayed inside the clock. It also has a countdown for seconds until the next presidential inauguration, a very American thing for July 4th. And he had other stats and details in it, so it has a lot of info in the center of the clock, but another round clock. So we have 2 round clocks, most ever. David Stells talked about and showed off his project that he did this week. It's on the Learn system. It's a NeoPixel Pomodoro timer for keeping track of work and break. You can program it with a rotary encoder. He pretty much wanted to play with a rotary encoder support on CircuitPython, which we added in 3.0. So he made the interface a rotary encoder. You can set the time, break time, and work time, and it has a chimer also with a buzzer. So a great little project. He said the code only took him an hour, but the 3D printing and design of the 3D printed case, which is a really nice case, took him 4 days. And that's totally how 3D modeling goes. Ray has one of these stream decks. We use them, little buttons from Elgato for streamers, and he wants to use it for programming for his IDE. But he doesn't like the software for the Stream Deck, so he's making a custom user interface, and he's looking to program, I guess, the chip itself inside of the Stream Deck. So that's pretty exciting. Mark made a NeoPixel shirt with like 1,000 NeoPixels using 6 8x32 NeoPixel flexi panels, sewed them to the front of his shirt, and he's using Fast LED and NeoPixel and NeoMatrix libraries to have various displays, videos, animation, text. Took it to some electronic dance party in Vegas, and he's going to take it to Burning Man. So this is good timing. Get your project for Burning Man done in July, and then you're not rushing around in August.
You have plenty of time to be late.
Because you're going to be late on something. Don't make it your project. Trust me, I've soldered on the ply. It's not fun. And then C. Scott played us out with a don't panic. He says don't panic. He's also talking a lot more in the Discord chat about it. He went through the list of all the tariffs that are being put in place later this week for Chinese goods. He read the Moog article, and he read Bunny Wang's article, and he kind of talked about what he thinks is actually going to be tariffed and what may not be. He doesn't think that everything's going to go up 25%. Some items will. Yeah,
don't panic yet. And the other thing is, a lot of it is you have to read a lot about what it actually is. So some things are like oscilloscopes, and that's probably because there's oscilloscope makers in the US. So you have to look at it. We're going through all of our imports, but we've always known prices are going to go up on things like shipping or components in general. There's a capacitor shortage anyways right now.
It's actually really funny. A couple months ago, we were told about the capacitor shortage.
Yeah.
What's funny is people did buy a lot of capacitors, but it's because they were running out of them. And so all the capacitor factories, they would contact their biggest customers and say, please put in your orders now because we're going to have a slow period for a couple of months. I don't know why there was a weird issue with that, but it's not because of the tariff. This was before the tariffs were announced. This was like due to something else, but it collided, right? So it's like there is now tariffs on capacitors and they're out of stock. So basically he said, don't panic about it. We'll see what happens, but
we'll let everyone know as we do our importing of components and more. We obviously we're good at this stuff, and if prices change, you'll see or we'll see, and all you can do is kind of live through this and get through it. I mean, like everything gets more expensive. Shipping costs is one of the things that goes up every year, and that's significant. It's more than 25%. Sometimes it all depends because things are getting heavier and fuel costs more. So anyways, hang in there. We'll start writing about this as we get real information on how it's affecting our stuff anyways.
It's definitely interesting times, and it does affect some tools and components that makers buy a lot of, but we'll see what actually gets affected. Also, some things that people buy are not made in China; they're made in other countries. So it's You know, it just because it's not made in the U.S. doesn't mean it's going to be tariffed.
Yep.
And he says he's going to be back next week with discussions about freight forwarders.
Yeah.
So tune in next week.
Okay, all participants on the show and tell
conclusion.
get an SC on the show and tell sticker. Email support@adafruit.com and we will send you a sticker. As part of our Adafruit live series shows, JP is going to be online tomorrow. He'll be showing some cool stuff. And I have a couple videos from his 2 recent builds, so we're going to play those now. Alright, a little reminder, tomorrow we are not doing the DigiKey together on Discord. It is next week, Thursday at 8 p.m. Join us there, and we're going to have some more Adafruit and DigiKey together in Discord.
But still buy stuff from DigiKey.
Yep, pack of the mailbag is here. We read these every single week at our State of the Fruit meeting. We also read these here for you.
This week.
2 thumbs up to the Rainbow Adafruit logo. I'm a nuclear engineer with 2 adult daughters. I'm very proud of them. I'm very supportive of Adafruit, the inclusion tendencies and promotion of science and engineering for everyone. Thank you, Lamore. Thank you, Adafruit. Keep it up. And when you wake up, look in the mirror, it's not just you reflected, it's all of us. We love what you're doing, Scott. Thanks, Scott.
Thanks, Scott.
All right, and don't forget, like I said, adafruit.it/Discord. Hang out in there. That's where we'll be doing questions. Towards the end of the show, we also have a very active CircuitPython community. Speaking of CircuitPython,
Dun, dun.
so we're
Break
gonna
time.
we're gonna skip around this week because we have some featured guides that wanted Lady Ada to talk about. She did something really neat.
I did something neat.
Yeah, and
I was left alone, and I just coded.
yeah. So I'll tell you what I thought was the challenge, and I think this is the solution.
What do you think the challenge is?
So the challenge, I think, is when you're using a Raspberry Pi, using hardware isn't necessarily easy.
That's correct.
So if you want to interact with hardware, you can do a bunch of GPIO stuff, you can get another board, you can do all this stuff. And if you're in the CircuitPython world, it's very Pythonic, Python-y. It'd be cool if you could take CircuitPython and run it kind of as is on a Raspberry Pi, and then do all the same type of microcontroller stuff that you want to do on a Raspberry Pi using CircuitPython, because that's what it's for, learning and sensors and all that. So you got that going.
Yeah. So let me explain the situation. So when you're using a Linux development board, like the Raspberry Pi, or even in some cases like the BeagleBone or Orange Pi or Onion IO, these Linux boards are basically computers, right? They're called single board computers, and they often have an I2C port, an SPI port, but what they don't have is some of those low-level peripherals that you're used to from an Arduino microcontroller or Arduino-like microcontroller. For example, they often don't have PWM outputs, and they often don't have analog inputs. The BeagleBone is like a really weird exception, but almost no other Linux boards have analog ins or have timers or PWM. They can't do servos, they can't do motors, they can't do capacitive touch input, they can't do analog outputs. Like, they don't have those things that make robotic projects or interactive art projects easy. Even if they do have GPIOs, there's no good standard way to interface with those GPIOs. In fact, the Linux kernel just went through a revision, and they're having a new kernel interface called GPIO-D, because they were struggling for so long with the interface that they'd had in Sisyphus, which people make fun of because it's named It's not named after the Greek story of the guy who pushes the thing up the hill, and then right when he gets to the top, it falls over, and he has to start over from the beginning. But that's kind of what it's like working with Sisyphus. It's named ironically. So when we did CircuitPython, CircuitPython is Python for microcontrollers. It's a variant of MicroPython. It's meant to run on the SMD21, Cortex M0, Cortex M4, these small microcontrollers. But when we were designing it, what I thought was really neat is we were designing such a good, stable hardware API that was broad enough to cover every kind of sensor and device I'd ever experienced in the last like 15, 20 years of doing electronics. That API could be also run on a Linux machine. And on the Linux machine, we could have interface chips like Seesaw, which is our I2C to whatever converter, or you could do I2C to PWM converters like the PCA 9685, or analog inputs converters like the ADS 1015. And CircuitPython does a really good job of abstracting these in a way that makes it seem transparent. Like you're not fighting the interface so much, and you don't have to pick and choose from all these different libraries like you have to do right now with Python, where like SPI is handled by one library and I2C by another library, and they're so different in how they work. So the upshot is over last weekend, I started the project of porting the CircuitPython API to the Raspberry Pi. And of course, we'll work on other Linux computers. Right now we have like I2C sensors, all of our I2C sensors work, and all our SPI sensors work, and the digital I/O stuff works. We'll be expanding this to other Linux boards, but right now the Raspberry Pi is just the most popular, so it's the one that makes the most sense.
So you wired something up.
Yes, this is an example of a VMA 280, a very popular barometric pressure, temperature, and humidity sensor. And what's nice is we've written code in Python for it, but it's dependent on, like, it's a little bit too dependent on the Raspberry Pi Python code that we've always written. By using the CircuitPython code, I only have to maintain one library. I don't have to maintain CircuitPython and Python. I have one library, one example, one documentation, and it's consistent between the microcomputers, like the Raspberry Pi, and the microcontrollers, like the Feather M4. So I'm trying to like unify these two worlds of hardware and make it so the code that you run on a Raspberry Pi can be the same code that you run on a Gemma or a Circuit Playground Express. This also means that as I start working on the hardware for the Cricket hat for Raspberry Pi, I will be able to just run that as is on the using CircuitPython. Like there won't be a variant with different behaviors. It'll act exactly the same. So it was, CircuitPython was inspired by GPIO 0, which is the Raspberry Pi, which is an excellent Raspberry Pi interfacing library. But again, that library is very Raspberry Pi only. We wanted to, instead of trying to port that to like the BeagleBone or the Orange Pi or like the Onion IO, let's take CircuitPython, which is designed to run on minimalist platforms, and get that going. Also, GPIO 0 doesn't cover I2C and SPI sensors. It's really for digital I/O more than sensors. And I think what people really like about Adafruit, people tell us they love, is we have these sensor breakouts and we have great documentation, great library support. So this feels to me like a natural progression of all the Raspberry Pi work we've done and are doing, and the CircuitPython work we're doing. So it doesn't have to with CircuitPython 3, but the fact that we got 3 out was like, yay, our APIs are really solidified. This is now the good time.
Yeah. Whew. So if you're doing physical electronics, it's just about to get easier. And what's cool is you could potentially control things like the HDMI signal or what's being shown on it, the output from a Raspberry Pi with CircuitPython.
It's just Python.
Yeah.
Like the CircuitPython API is implemented within the everyday Python 3.6 that you get with the Raspberry Pi. So you still get access to the camera input, and the HDMI output, all the USB ports, all of that intense hardware, MP3 decoding, mixing, all that stuff you can still do. But the part that I think Adafruit people like the most, which is integrating sensors and robotics, that now comes with it. And we've already designed all the API and layers to make it So it works really well together. I think people are going to like how we end up doing this. And then as a sneak peek, one of the other ideas I had is the MRA library, which is what we're going to use to support other boards, also supports the FTDI USB to GPIO chipset. So we could actually have CircuitPython running natively on a computer. And you use the FTDI board as your gateway bridge, but you're still running the CircuitPython like on your Mac or on your Windows desktop computer in Python, and then interfacing with hardware. So no microcontroller or microcomputer at all. That could be really good for people who want to use their computer for something and then have that control hardware, which is, again, people have taken Arduinos and they've kind of like glued stuff and they've used Fermata, but it's never been, in my opinion, a really elegant, transparent interface for hardware and Python. So CircuitPython is kind of growing up. It's maturing into a bigger project than just running running a minimalist Python on a Gemma.
No, the easiest way to interact with hardware. That seems like where it's heading. Yeah.
So the upshot is, please try it out. There's a guide.
Yeah.
If you have a Raspberry Pi, again, we don't support other Linux boards quite yet. We will. But on Raspberry Pi, we've started putting all of our libraries on PyPi, so you can just like pip install. Check out the guide. We have Digital I/O, SPI, and I2C working right now. And as we add more libraries, you'll be able to access the wide range of hardware and hats through CircuitPython.
Yeah, one thing I would redo a project, I made the little Cricut bubble blower, so it dips, servo dips the little bubble wand, and then a fan turns on and it blows the bubbles, and I had a projector, and it had a video of me blowing the bubbles, and it looked neat because it looked, kind of like those Disney projections where they project the face on a curved surface. I thought it'd be neat to do a version where the video is changing based on what's going on. So it's aware. So Raspberry Pi is perfect for that, and like the Pi plus Cricut, because we'll be launching that soon. The Raspberry Pi Cricut. You could do that. You could have the videos aware of what's going on with the
super
hardware.
easy.
So anyways, that's a freebie project. Someone should build that.
Whew.
Okay. So
that's the big story.
Yeah, we covered that in our Adafruit Daily. Our particular one that we send out is Python and microcontrollers. Sign up for it. We also added a new section. It's Moo. And it's Made with Moo. There's a new blog. Go to Made with Moo. Subscribe whenever reader type entity you use.
It's great.
And each week now, or even more than that, there's a new project. So this was on the Made with Moo blog.
This is a clock, built with a Trinket M0 running CircuitPython. And I read this post. This person was like, I really just wanted to build something that was the clock that I wanted. It's like a perfect clock, and they did. And they did it all in Python using Moo. And the code wasn't even that long because we have so much good hardware integration.
Yeah. So on Adafruit Daily, that's where you go and subscribe for this. We also link to the MicroPython newsletter.
Yes.
Our newsletter links to newsletters, and there's some new MicroPython hardware
Check this out
as well.
Cortex M7 coming soon.
You want to sign up for this stuff because this is where it's happening. So we have a few thousand people who read now. And
these are good newsletters.
Yep. Go to adafruitdaily.com on that. Okay.
Okay.
Time travel. Some news this week. We'll get to new products and videos and more in a second. The news this week is, of course, besides, Happy Independence Day.
Happy.
We just hit 7,000 people on Discord. So everyone in Discord right now, yay, the thousands of you that are online. 7,000 people. We blew past 2,000, 3,000, 4,000, 5,000. Now we're up to 6,000. 7,000, we'll probably be up to 10,000 soon. So it's the largest online 24/7 electronic community. So thank you everyone out there who's joined the Discord. It's super fun.
Everyone's great. I love seeing people help each other, share their projects, show off what they're working on.
So we had 7,000. That was a big deal. And then I don't have a Cricut video this week, but we do have this cool Cricut video that Noah and Pedro made. This is kind of like a Cricut assembly video. And
oh my God, this is so cool.
So you see how to put the stand on. So this is the new video that I'll show as we showcase some Cricut projects. And then nice, it shows where to put the stand
It's like the IKEA of electronics.
Bing, bing,
ding, 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 ding.
Yeah.
Oh, that's so cool.
Okay.
Nice modeling work.
Open source hardware. We're an open source hardware company. To prove it, we have guides. We have.
Oh, wait, how many guides do we have?
Well, we have 1,501 now.
I know, because we did one
So
right afterwards.
we hit our 1,500 guides. I think
Yes.
Mike Barella, who's in the chat, congratulations. I think you were guide number 1,500 or 1,501, one of the two. It doesn't matter.
Noah and Pedro and Mike Burrell's guide were basically live at the same time. So I'm going to
Yeah.
say it's a tie, and all three of them
Yep.
can say they're the 1,500th guide.
Okay, so Lady Ada was on the big board this week. You don't have to go over your other guide, but what were the other ones?
Right. You can see the CircuitPython Linux Raspberry Pi. I ranted about that for a good 5 minutes. You know about that. We got the Firework Igniter. Noah and Pedro will show off some video about that soon. Nintendo Labo inspired Cricut, the cutter robot project. And when they mentioned, I said, hey, let's do something maybe 4th of July themed. So they're like, yeah, let's use it to set off fireworks. And like, who doesn't love that?
Yeah.
CircuitPython with Jupyter Notebooks. This is also a really interesting guide. This is from Brent. If you're learning Python these days, you're probably using Jupyter Notebooks, which is a web-based system with cells that you can have graphics and plotting, and you can have your code in chunks with text in between. So it's like not only is the code self-documenting, but there's documentation documentation. And he made a notebook with CircuitPython that runs on the Circuit Playground Express. So the kernel, instead of running Python on your computer when you're running Jupyter Notebooks, it's actually running the CircuitPython on your CircuitPython board, the Circuit Playground, or the Trinket, or the Feather. And the commands you run, they're sent back and forth over the REPL. So it's a kind of interesting way of storing your CircuitPython project, where it's not stored on the board itself, it's stored in the web browser, and you can run each cell one at a time. It's a little bit advanced because you do have to like do some installation and software, but if you've ever used Jupyter Notebooks, this is kind of neat, and this is kind of an interesting mix of the academic Python that we've seen and CircuitPython. Another cool thing is you can then share the notebooks, which have, again, these graphics, the text, and the code all embedded. So if you have a project, a Jupyter Notebook might be a good way to share it, where you have wiring diagrams and hardware information and like a schematic, but then you also have the code embedded. And it's a cool guide. We also have the NeoPixel Pomodoro timer. David Stell showed that on Show and Tell. You can make your own rotary knob-controlled Pomodoro timer with custom timing, CircuitPython, Cardboard Fundamentals. This is a massive guide. JP's been working on it for like over a month. All the different skills and techniques you need to do all sorts of cardboard crafting. If you're getting started with building stuff with cardboard, it's a very versatile material. His guide has like half a dozen pages about different tools and techniques that you may not have known about, including our rivets that we put in the store that make it really great. You saw a little video, great for making hinges. Kattni also published a huge guide about CircuitPython, Git and GitHub. It talks about the workflow, how we get pull requests, how we do reviews, how we can include your code. It's about the CircuitPython repository and the code that we do, but it applies to like pretty much all GitHub and Git projects and repositories these days. It's a very common workflow. Blues Playground, I think I chatted about that last week.
Yep.
And the Pi-hole ad detection,
We have
that's
one
last
more.
week too.
This just launched.
Right.
This is the Make It Move with Cricut. Mike B just published this. This is, we have all these Cricuts out, and a lot of folks just want to take a motor and just get it going. One, to test and see if the motor's wired up right. Two, like, how do I do it with MakeCode? How do I do it like CircuitPython? So that's this guide. If you have a servo, you can get up and running in 5 minutes.
No,
not even.
It's like 30 seconds. So this is a massive guide, and what's interesting about this guide is its simplicity is deceptive. There's a lot of really good information about this. All that we've learned, Phil and I, from doing, like, we basically did a crash course, learned everything about robotics in like 2 months. And everything that we learned in that process, all the questions we had, all the issues that we bumped into, we put that into this guide. So it's general, it talks about the kind of motors and motion that you can use with, you can do with Cricut, and provides little snippets of code that just do the kind of motion and activity that we found people doing over and over and over again. It's like the hello world of robotics, but for all the different kinds of motors. We also have like in-depth discussion of the kind of motors you can use, and like what's a continuous rotation servo versus a standard servo? What's a DC motor versus a gearbox motor? These are questions that like aren't covered anywhere. Like there's no good.
Yeah, when you look
blogs.
online, if it's like here's a servo and it goes through the history of servos and like all the different ones, and then all the websites that they link to don't work, and eventually maybe there's a snippet of code, but it's for something else and that you'll never be able to use, and it's like cut your teeth on, you know, do it the hard way. So what we want to do is start with make it move. Like here's how you make it move, and then here's all the information about why it moves, all the different types of things, and it's very like card format where it's like flashcards, like, oh, I want to do this, so I can cut and paste and I'm off to the races. So it's project based, but it's also I want to just do this, and then I'll look and I'll learn more as I want to do more. Yeah,
this is a great, after you've gotten your Cricut put together, this is actually the first guide. So I'm going to actually add this to the Cricut guide and say, hey, read this first so you know, when I talk about what it's like, you know, plug in a servo, you can see what it is and get it going really fast and test it out. Because that's until you see it move, you don't know. So that's by Mike Barella, who did an excellent job with this guide.
And one of the follow-up guides, I'll probably talk to Mike later about this, is let's see how quick and easy we can do Hello World for robotics. And so Hello World is you get a robot to say Hello World and wave.
Literally.
And what's the minimal amount of lines of code, and how fast could you do that?
In CircuitPython now?
Because imagine a workshop where it's a Hello World workshop and it's a matter of minutes, not hours. No software to download. You could piece this together, and within a few minutes, 30 kids all have something waving and saying Hello World. Like I haven't seen anyone approach robotics like that.
This is
like, no, like get out your calipers and like start ordering a ton of expensive stuff.
Get $300 worth of robotic drive. It's pretty intense.
It's a different approach.
Also, this guide has the example code in both make code, block drag and drop programming, and CircuitPython. CircuitPython code, none of the code examples are more than like 15 lines, and the make code is only a couple blocks. Very powerful. Press a button on the circuit playground, servo moves to a location, or motor turns on and off.
You can drag and drop a few blocks. You can switch over to JavaScript. You can use CircuitPython. And then the last part about this is this moves robotics closer to its experiences with robotics. It's not just read 500 pages and then maybe later one day, after you invest years, you can get a robot to move. This is experience-based learning for robotics, opposite of the way robotics has historically been distributed.
Everything about the robotic stuff we've been doing is all based on my experience doing 6270, the robotics competition at MIT. It was so traumatic for me. Like, I had fun, but it was like, we spent like a week building a gearbox. Like, it was like, it wasn't until like week 3 when we actually got to move the motor. It was terrible.
And you were at MIT, and that was...
This was MIT, this was like the top of the top.
But that's the point maybe for MIT, but for everybody else...
No, it's because they just didn't have a good...
But for everybody else, like you get a robot kit, you're not at MIT, you're doing this as a hobby, and you don't really want to wait 3 weeks for your first, like, I got it to move. You really want that experience, that very first thing, and that's why I think the microcontroller market recently got exciting for people, because you can kind of get something going pretty fast. Robotics was still far behind, so we think we're getting closer to solving. But anyways,
we're cracking it. It's challenging though, because we're fighting against 25 years of kind of mediocre robotics, in my opinion.
Yeah. So
okay. Anyways, check out this guide.
Yeah. So there's folks in the chat. They're like, "Oh, I need this guide." You do.
Well, you do, and now it's live. Go read it. 1,500 guides, everybody.
Yeah. Okay. Whew. So here's some factory footage. Take it away, Adafruit Factory. always, we have the factory footage and a sunset, or a sunrise, or a skyscape.
Yeah, skyscape.
Shot outside Adafruit factory, where the picking place is.
Oh, I saw you. Yeah. That's nice.
Yep. Okay, 3D printing. Noah and Pedro showed their project on the show and tell. I think the only live cardboard launching fireworks ever on the history of the internet.
Yes.
Eventually, there'll be an entire channel devoted to that.
I know, but for now.
For now, so take it away, Noah and Pedro.
Hey, what's up guys? In this project, we'll show you how to build a firework igniter. This DIY electronic igniter is perfect for setting off fireworks from a safe distance. It's a great way to launch explosives without having to use lighters or matches. This uses two 9-volt batteries to heat up a small coil of Kanthal wire. Kanthal wire is great for high temperature applications that need resistance heating. Our button was constructed out of chipboard and was inspired by the Nintendo Labo. It features a spring mechanism that allows the button to be held momentarily. We made this into a downloadable template that you can print and cut out yourself. We think this works great with other projects like the Circuit Playground Express. The box enclosure is easy to take apart and put back together. It houses two 9-volt batteries, copper tape, and a set of alligator clips, so there's plenty of room for additional electronics and components. We used a vinyl cutter to cut our design out of medium weight chipboard. These cutting machines can make precise cuts that are great for making intricate designs. They can also score fold lines, which makes this a nice alternative to a laser cutter. Each piece is removed from the adhesive cutting mat. Tiny voids can be removed by poking them out. For really sharp corners, we used an X-Acto blade to lightly cut the top surface of the chipboard. This makes clean and crisp edges that are nice and square. For a detailed step-by-step tutorial of the button assembly, check out our Learn Guide. Links are in the description of this video. Strips of copper tape can be attached to the bottom of the actuator. To make this modular, we made a little tab for attaching alligator clips. Inside the box enclosure, we can plan out our circuit and lay down strips of copper tape. A longer piece is used to connect the positive wire, and a shorter piece will connect to the negative wire. We can connect wires to the tape by sticking smaller pieces on top. The adhesive in our roll of copper tape is electrically conductive, so we can layer them. We can DIY our own custom battery connector by wiring two 9-volt jackets in parallel. This way we can plug in two 9-volt batteries and only have one end like this male JST connector. Heat shrink tubing can help insulate the exposed wire and avoid short circuits. These alligator clips feature male jumpers, so we can simply plug them directly into the JST connector from the 9-volt battery. The button can now be fitted into the box enclosure. It fits in snugly and holds in place with friction. Now we can attach the alligator clips to the tabs we built into the strips of copper tape. The second alligator clip is attached to a strip of tape on the end of the button actuator. Be sure to check your wiring before closing everything up. We thought we'd get crafty, so we decorated the outside with this TNT graphic from Minecraft. You can get a spool of Kanthal wire from your local store or online retailer. We built our own coil by wrapping it tightly around a cylindrical object like this screwdriver. We found the tighter the winding, the faster it'll heat up. We can connect another set of alligator clips to the other end of our wire setup. This gets so hot it glows bright orange, so you want to be very careful not to accidentally touch it. We got ourselves some lengthy fuses so we could extend our setup. These come in different sizes. This thicker fuse will burn more quickly and emits large sparks. You can attach the extension to the main fuse with a piece of paper tape, and this will give you extra time to back away when it gets ignited. We think this is a safe way to light up fireworks, and it's a great way to get young kids involved. They can light up fireworks at a safe distance without the danger of burning their fingers. It's also great for assistive tech, so folks who might not have the dexterity in their hands can still set off fireworks. We hope you have a safe and festive holiday this summer. Thank you so much for watching, and be sure to subscribe for more DIY projects from Adafruit.
And of course, we have a sped up video in case you don't want to sit around for 4 hours and watch something print.
I hope it's a dinosaur.
You could do it in 40 seconds.
Yay!
And don't forget, every Wednesday, 3D Hangouts with Noah and Pedro. Today they showed some cool gears made out of cardboard that they cut on a paper cutter. That was a fun project. Do check that out. Okay, before we get on the new products, don't forget, if you have an Adafruit account, you can sign up for the new product newsletter. It's the only one that we have. You're not signed up for it automatically. We don't do weird pop-ups or anything. You have to have an account, though, and then you have to go in your preferences.
That's
and then
popular.
click that. Yeah, it's the most popular one,
Okay.
but we do not spam you, so you do have to try hard to get this. And the code is America Day.
Yay, America!
Yeah, so let's kick it off.
Okay. New, 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 new. New, 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 new. We got a lot of new.
Okay, let's do it.
Kick it off. We got 3 enamel pins. The Boomy enamel pin, this friendly boombox, will hang out with you while you work on your music maker projects. We also have the feather enamel pin. This one has the logo for our feather boards. It's the #1 search on our site. You know, get a pin that shows your feather love. It's got that circuit board trace and the beautiful blue enameling.
Yep.
And we've got the Adabot pin. Everyone loves Adabot. The Elmo Electronics, as sometimes we say. Our character that appears in our videos and in our guides and a lot of our tutorials and stickers. You can now wear Adabot with pride with this enamel pin.
Yep.
Okay.
More wearables, sort of.
Okay.
Here we go.
You also have
These are cool.
from Borgatti in Brooklyn. These are made in Brooklyn. These really cool chandelier earrings that are also lock picks. You get a torque wrench, looks like a diamond, a feeler, 2 rakes, and a round pick. Looks like it's just like a normal, everyday, fancy earring, but they actually are working picks. We sold out, but sign up, we're going to get more.
Yep.
These are just beautiful and awesome to wear to show off how much you love lock sport, and they're kind of fashionable too. I like the look of them.
Okay.
We have an updated product, the Maker Paste.
Made from real makers.
Stop. Now this Maker Paste is paste for doing reflow or hot air. It's a metallic paste with flux in it. You can keep it. If keeping it cold will make it last longer and it'll work better. But you can also keep it not refrigerated if you absolutely have to and you want to use it pretty fast. It's now lower temperature. That's the big update here. So check it out. It's a eutectic. No, sorry, it's not eutectic. And yeah, it works at much lower temperature, so it's much easier to work with. This is an updated product. We've had it for a bit, but it's a new formulation.
Okay. And then we have, these are updates, and they're also new.
Update new. So this is the Code.org Educator Pack for people who are teaching. In particular, it's for teachers or workshop runners who are teaching CS discoveries from Code.org. It's an online learning curriculum. It's a full year curriculum, learning how to program, and they use Circuit Playground as the hardware that they interface with, which makes it more interactive and fun. And we've updated the firmware to now support Circuit Playground Express. And Circuit Playground Express now comes with Fermata, so it works out of the box with Code.org. And so we've updated this pack, the Educator Pack, which has 15 boards, basically enough for 15 students individually, or 30 if they're sharing. And we also have, the next one is the individual student or learner kit. If you don't want to teach a classroom of 15, maybe it's only 2 or 3 people, you can buy individual one-offs that have 1/15 of that project pack, and you can just follow the CS discoveries on your own.
Okay, and star of the show tonight, besides you, Lady Ada, in the community, is we got to make robot friend puzzle.
Yeah, Adabot. Remember how much we said we loved Adabot? We've got this puzzle that we made from Bruce Yan's beautiful illustration of Adabot holding hands with 2 humanoid friends. now comes as a 36-piece jigsaw. Really good for your first jigsaw puzzle, maybe for younger makers.
Yep.
You also put it together and frame it and put it on your wall.
Comes with a little card. I didn't do a sticker this time because you might want to put this as a little cardboard thing for making a robot. And we have some instructions on the back.
And of course the tagline, make robot friend. This is kind of our motto for robotics. You can see it on the front of the puzzle. Is also on the back of the little insert to remind you to make a robot friend.
Yeah, this is really good to have when you're making a robot project and you have little kids around. They can work on a puzzle of their own and make a robot friend while you're working on robots. So
yeah,
and that is the new products for this week, Lady Ada.
That's right. Okay.
Okay.
Let's kick off.
Here we go. What do we have this week?
This week we got some enamel pins. We got the Boomy Boombox pin. Make your musical projects and wear this enamel pin to show how much you love audio projects. We have the Feather pin. It has the logo made real of our feather boards, a very popular feather lineup. We have an Adabot pin, our adorable puppet, who is a star of many projects and videos, and now available as an enamel pin, all limited edition. We've got these really cool chandelier earrings. Oh, they look so great, but wait, what's going on there? That's right, it's a set of lock picks. You can now take your lock sport with you, torque wrench and 5 picks to go, and easy to store. Just put them on your face. We have an updated formulation for maker paste. It's now lower temperature, so it's easier to use when you're doing hot air or reflow at home or in the lab. And we've updated the code.org individual and educator packs. They now come with Circuit Playground Express, which comes pre-programmed with Fermata. You can now use a Circuit Playground Express in your code.org CS Discoveries curriculum, either as a classroom for 15 students or individually. And finally, we have this beautiful Make Robot Friend jigsaw puzzle featuring Adabot holding hands with 2 humanoid friends. Also comes with an insert. It's a great puzzle for younger makers who want to share in your robotics project, maybe aren't quite ready to solder yet.
All right, okay, and don't forget the code is America Day all the way up to 11:59 p.m. Eastern Time tonight, or until we turn off the code after you watch fireworks or something. Lady Ada, let's answer some questions.
Yeah.
We do that in Discord.
On Discord.
Yeah.
Join the 7,000 other people who have agreed that the Adafruit Discord channel is an awesome place to hang out and talk about robots, electronics, crafting, 3D printing, wearables.
So put your questions in there. And I think one thing about Discord, the Adafruit community in particular, I think it's really easy just to say, you know, all online communities are garbage. Well, it is what you put into it. So we put a lot into it. So thanks for all the people who work on it every day, all the helpers that are in there now and the staff, because it really is a reflection of what's possible. So, you know, 7,000 people, that's pretty fast. And there's other online communities, and they're not really going to say, hey, look at this great community over there. This was built by all of you.
I love it. It's like the only online chat place that I hang out, and I spent a lot of time in IRC as a kid, so I'm really glad that
it does have all the good things about
the
IRC,
best parts about IRC,
and it leaves all the bad things.
None of the bad parts.
It's like we had like a server split, and
bad
stuff goes, good stuff continues forward. Okay,
it's pretty much.
So here's a question: what's the biggest difference between FTDI cable versus FTDI friend? It seems that the FTDI friend is more capable. The cable is costlier. Am I missing as to why is that?
The reason that is a good question. The reason the FTDI friend, in my opinion, is more capable. The reason the cable is more costly is because you're paying for that cable and the USB connector and that molded over cable part. That does cost money. It requires cable assembly, whereas the FTDI friend is kind of all pick and placed. So it's only that inner part. I like the FTDI friend, but the cable is kind of, in a sense, more durable because it is enclosed and it's got like that plastic case and the plug. Use whichever you want. The chip inside is the same. The wiring is the same. But, you know, you can configure the FTDI friend a little bit more.
Okay. For the, where did it go? How big are the lock sport earrings? So we have a, we have a,
I can show it on the overhead real fast.
Yeah, we have that for scale, but let's use this overhead.
Yeah.
That's
okay, so this is my hands, and this is my pen. You can see how big they are. So they're chandelier earrings. They're long, but they're made out of very thin, strong metal, so they're not very heavy. I don't remember exactly how many grams it is, but they're not as heavy as you might think they would be because the metal is so thin and so strong. And they've got these really cool cutouts as well to lighten the load.
Okay, is there a CPX update firmware to Flash yet?
Well, if you're using Arduino, you upload the new firmware every time you program the Circuit Playground Express. If you're using CircuitPython, we have new releases constantly. We released 3.0, release candidate 1 or 2 only a couple days ago. Check the CircuitPython releases page to get the absolute latest CircuitPython code. 3.0 is recommended now. It's working really great and really solid. And for MakeCode, they do make improvements to the runtime. And again, every time you download a MakeCode project, you're downloading all that firmware with you. So those are the 3 ways you can update firmware.
Yeah. Someone asked, and this is more for the chat room, what's the youngest they've ever taught a kid how to make something? So I think based on what we've seen from show and tells and photos that come in and just parents and grandparents and just friends of kids stories, it seems like if someone's handing a kid something with a screen and they're able to see something, that's like, so it's like 1 and 2 now. It's a lot younger than it used to be because a lot of the stuff has sensors and you touch something, it buzzes or beeps. I remember there was one that a parent worked with their kid for a special type of light.
The night light,
The night light, so it would help them know what time it is to go to bed without needing to read numbers.
Yeah.
So it was like color-based.
Yeah, that was kind of cool. I mean, there's parents who are working with kids. You don't have to start them with soldering. They can help you design the project. Maybe they pick what color the LED is. You know, they can tell you what they like the most if they're ready to communicate. And if they're not, you can just make something interactive. I mean, kids love to press big buttons. Like all kids' toys do
it's
that.
Earlier. It's earlier and easier, and it's also when you make something with the kids. Like even if you're just doing like a cardboard project, a cardboard box project, the older kids or the parents can do something that makes it electronic and interactive, and the younger kids can just color it in and do stuff. That's why the mini golf thing, I think we'll see, because we played some of the mini golf projects, I think we'll see that as a great way to bring people together, because everyone can bring their own creativity to their own little mini golf hole.
And it doesn't really matter how old you are. It's the mini golf is kind of it's a more random game than a game of skill.
Someone's asking about Bluetooth Bluefruit LE sniffer. Is it still supported?
It is, but the firmware for the Bluefruit sniffer we didn't write. It's Nordic's firmware. We're going to have a revision of the sniffer soon with 2.0 with the new Nordic firmware. But yeah, make a new thread. Sometimes people reply to old threads on the forums, and so we don't see them, whereas we always see new threads. So just make a new thread, and we'll help you out. But yeah, the Bluetooth sniffer still works just fine. I mean, nothing has changed with Bluetooth Low Energy. Yeah.
Someone pointed this out. Thank you for doing cardboard projects. I thought it was the only one without a 3D printer for enclosures. Yeah, that was one of the main reasons we did it. One like hack, I guess you could say.
Yeah.
If you're not going to buy a 3D printer, you're just like, I don't want to wait around for that, and but I do want to have something that helps automate some of the things I build. Go to a craft store or go online and just look at all the videos of the paper cutters, because you can do a lot with
They're
paper.
popular, and you can buy them in stores.
Yeah, and also just straight up cardboard boxes, putting all your electronics in those, and at least you get to the point where it's like, okay, this is something I may want to send off as a 3D file and get it printed.
That's right.
But it's a really easy way to do it fast and cheap. There's so much junk and garbage. Also, plastic containers are fantastic.
People, I mean, those really thin Tupperwares, not the thick ones.
Yeah.
But the thin ones you can cut carefully with the blade. People love those. You don't have to do any machining. And then I know that you said that there was like cardboard box generators online that you saw. Yeah. So you can type in the dimensions you want, and they'll tell you, they'll make a file that you can print out and then cut cardboard to make a box at any particular size.
I think one of the stepping stones, like for whatever reason in the maker world, it skipped over to like $2,000 3D printers, but there was an intermediate thing that the crafter world, the scrapbooking world, figured this out. Like, go look at what the scrapbookers do, because they're using all these materials, they're making something that's an heirloom. Look at that section in a craft store, go to those videos online, and you'll see like, oh my gosh, electronics are not there yet, but they will be, and like you could take all that stuff that people are doing in that world. So you could save a bunch of money before getting a 3D printer to start on this stuff.
I mean, they're CNC machines. I mean, there's no question.
Yeah.
They're low cost, they're mass manufactured, and they're available right now. No, they won't cut through wood, but they can cut templates and through thin cardboard and sometimes even thicker cardboard if you're willing to wait.
Last question.
Yeah.
Will a Power over Ethernet hat be available for the Raspberry Pi B Plus at Adafruit?
The official Raspberry Pi PoE hat, I've seen a photo of it online. As soon as the Raspberry Pi Foundation releases it, I'm sure we'll carry it just like we carried the Sense hat.
Yeah.
But yeah, for the B Plus, I expect that there will be some PoE hardware coming real soon.
Okay. And with that, Lady Ada, those are the questions.
Yay!
Okay, so you want to give something away?
Yeah.
What do you want to give away this week?
I thought we would give away one of the AdaBot puzzles.
AdaBot puzzle, that's a good gift.
Yeah, that's a good gift.
Okay, what are the rules?
Rules are if you've won something before, you can't win again. Only one winner per my lifetime on this show. Other shows may have different rules, but that's this show. When you call the phone number, as it appears on the screen, I'm going to pick up the phone. After 2 rings, I'm going to ask you your name, where you're calling from, and a project you're making or you want to make. Answer those 3 questions. We will send you out this AdaBot jigsaw puzzle.
Yeah. So that's the phone number. Sue's around on a 4th of
Independence
July.
Day? Yeah, no, there's people.
So that's the phone.
Wait.
The phone lines are now open.
Yeah.
So that's the phone. You have to decipher
Call.
on Bitstab.
Yeah, turn that into numbers.
I'll see who
Call
calls
the
tonight.
phone. You'll win a prize. There must be somebody
Yeah, that's
who
probably
hasn't
someone.
won something that wants this jigsaw puzzle.
Boop. So they're gonna win. Let's see. Let me get it
It's the
ready.
last item, yeah.
Yeah, so this is the prize. All you have to do is call. Let's see who calls. Ring, ring, ring. We haven't had a week in a long time where there was nobody on the telephone.
I'll just add more, I don't know, add more time to the show until people
Yeah.
call up.
Do, 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 do,
It's
do.
100 people watching.
Yeah, all you have to do is call the phone number.
Call phone number.
And you win.
Win. And you get to talk to me.
Yeah.
Oh!
Well, there's also the delay. I have to remember.
That's true, yeah.
Like, it took a little while to start.
Hello? Hello, you've reached Ask an Engineer. Hello?
Hi.
Hi, you're the
Wait, wait.
winner. Hello?
Hello?
Hi, you're the winner. Congratulations.
Yay!
Yay! What's your name and where are you calling from?
My name's Jeff Wurz, and I'm calling from San Jose.
Hey, Jeff from San Jose. Well, congratulations to the winner of this wonderful jigsaw puzzle. All you have to do is email support, SUPPORT, at adafruit.com, and tell them, hey, it's Jeff from San Diego, and I won a 3817 jigsaw puzzle. That's the part number, and they'll send it to you.
3817.
3817, yeah, that helps them a lot. So what's a project you're working on or you want to work on?
I'm building a couple, like, synthesizer-type projects, and
Awesome.
built a mini unit and a couple other things.
Sweet. Well, we would love to have you on show and tell if you want to show off your synth. You can even play it live.
Actually, yeah.
That would be so sweet.
All right.
Well, thanks so much for calling in, Jeff, and congratulations. Have a great 4th of July. And don't forget to email support at adafruit.com.
All right, thank you.
All right, thanks. Good night.
Bye.
Bye. Congratulations, Jeff.
Success.
Success.
Okay. Well, that's the show for tonight. Thank you, everybody. Stay safe tonight in the world of pyrotechnics and more, if you're lighting off fireworks or even if you're just seeing them. We'll be back next week. Don't forget the code is America Day.
Yay, America.
Save 10% off all the way up
Everything
to
was
11:59 p.m. Eastern Time, celebrating today, Independence Day.
Yay. You could buy these LEDs and make that LED flag.
That's right.
Yeah, you can have that all year round.
And we'll see everybody next week. Thanks so much, all the Adafruit team members here, remote, the Adafruit community, everyone in
Thanks,
Discord.
everyone.
Happy 7,000 plus people. We'll see everybody next week, and keep on making and sharing.
All right.
Here's your moment of Zener.
Bye.